Variables are helpful for making packages more versatile, letting you run them in various servers. For example, you could store paths in a single location and use them throughout a package. That way, you only need to change the path in one location when you move that package to another server. Integration services tasks can't access the package object model as such, and so tasks can't share information through that object model. Variables provide a mechanism for the separate tasks within a package to share data with each other. Variables fit into two main namespaces. The first is System. The System namespace contains read-only variables that the integration services runtime supplies automatically, so you can use them in your package. Examples of System namespace variables are start time and machine name. Start time provides the time at which the package execution began, and machine name provides the name of the machine that the package is running on. And then there's the user namespace. This contains the read-write variables that the integration services developer declares within a package. The system variables are fixed, so you can't add or remove those variables, or change their value. You can change the namespace for any user-defined variable to something other than user, though. But in this course, I'm going to stick to using the user namespace. Now, when you declare a variable, you can set various properties to configure the behavior of a variable. So this shows a variable's properties window, which is available when you have the variable selected within SQL Server Data Tools. The figure shows all the default values for a variable's properties, including the rather unimaginative default variable value for the name property. So you create a new variable, it's called variable. Notice that each variable has a unique GUID ID property. You can see that in about the upper third of the figure. It's read-only, so it's grayed out, so it's disabled. So, like all the other objects in an integration services package, this ID value is used internally in order to manage objects, in this case a variable. Now, there's a few properties that are particularly interesting or that you'll use most often. The first, of course, is the name property. This is the name of the variable by which other parts of the package are going to access the variable and its value. Variables are meant for reference by other objects, and therefore, of course, require a unique name within the variable's scope. And I'll talk about scope a little bit later. As with variables in programming languages, choose a name that indicates the use of the variable or the type of data that it contains. You'll always want to change the default name from variable to make it more meaningful and identify the data that it contains. And then there's the value type property. This exposes the type of value that the variable holds. Integration Services is type safe, meaning that it validates that the data contained in a variable, or that you're trying to save in a variable, is of the declared type. And so this prevents all kinds of problems, just like in programming languages. And the default is int32. Then there's value. This, of course, holds the variable's stored value. When you create a variable, you can set a default value for that variable. But often, you'll have a control or data flow task that initially sets the value and maybe updates it as the package executes. And then there's the namespace property. As with a lot of programming languages, including the ones that are based on .NET, Integration Services let you create containers for variables. And this becomes part of the fully qualified name of that variable. Now, the default for all of your custom variables is user, but you can change that to create custom namespaces, so you can compartmentalize your variables throughout the package. But all predefined system variables have the namespace system, and you'll see that often as you work with variables. Then there's a qualified name property. This exposes the name of the variable together with its namespace in the proper format, which is namespace, 2 colons, and name. If the variable has no namespace, only the name shows. In fact, if the variable has no namespace, it just means that you've renamed the namespace to an empty string. So it really does still have a namespace. Then there's a raise changed event. And this controls the variable value changed event. If you set this to true, the variable raises this event whenever its value changes, so you can write code in order to respond to that change. So again, that's part of making packages very dynamic. The scope property is a read-only property that reflects the container in which the variable was created. Scope appears as a property of variables in the designer. But scope is not really a property of the variable object as such, but indicates the variable's container. Then there's evaluate as expression. This controls the use of the expression property. If you set evaluate as expression to true, the variable returns the result of the expression as its value. If you set it to false, the expression is ignored. This gives you lots of flexibility in how a package determines a variable's value at runtime, even to the point of letting you dynamically set whether the variable's value is set using the expression or some other value. So using an expression is analogous to using a formula in an Excel spreadsheet instead of a static value. And then finally is the expression property, and this holds an integration services expression that will be the variable's value if and only if evaluate as expression is set to true. Now, an important thing to know about variables is that their names are case sensitive. You can use any casing standards that you want, but make sure you use the same casing for a variable throughout a package, otherwise you're talking about different variables. Integration services variables are strongly typed, making it a type-safe environment. You can select a variable's type when you create the variable, or you can change it in the Properties window. The types available for a variable is a much shorter list than the data types that are available for data in the data flow of a package. This is because external applications can set the value of variables, so they're implemented as COM variants. As a result, variables are more generalized types than those that are available for data flows, the data flows that handle data coming from various data sources. And all strings are Unicode, so be careful to do a conversion if you interact with non-Unicode data in a data flow. This is going to be most common when you're importing from things like an Excel spreadsheet or flat files, so that can really trip you up. You also have to deal with truncation issues, because the variable string type doesn't let you define a length, unlike the data flow types. For dates and times, there's only the date-time variable type. Because SQL Server, for example, has both the date and time types, you may need to extract only the portion of a date-time variable that you need in a data flow. And then there's an object data type. This is typically used to store any kind of large data structure, things like a data set. It's roughly analogous to the system.object class in the .NET framework, although data types and integration services aren't full objects. Okay, so that's a lot of the details with control flows. Because you're working with variables, and those have those limited generalized variable types. But data flows, on the other hand, have to be able to handle most of the data types of the data sources and destinations that you can use in a package. So the data types you'll work with there within data flows often require casting to an explicit type that integration services supports if you need to mix and match variables and a data flow column in a single expression. And in the part of the course where we talk about expressions, I'll talk a little bit more about that. All right, this all leads to an unfortunate aspect of creating integration services packages. Depending on where your data is coming from and going to, you'll need to deal with data conversion issues. Various data providers, such as those for SQL Server and Oracle databases, as well as flat files, have their own data types, while integration services uses a couple of type systems internally. So it can all get very confusing very fast. All right, so here's a table that shows all of the variable data types available in a package down in that first column. And then the other columns show the equivalent data types for integration services, SQL Server, and .NET code. Now, this table is far from comprehensive. There are many other possible data types as well as myriad other type systems. So a comprehensive table would have to have many more rows and columns. So this is essentially a summarization of some of the kinds of issues that you'll be dealing with. All right. And also, as you can see from the blank cells in the table, there isn't always an equivalent type across type systems, nor is there always a single comparable type. And I indicated the latter with the various in angle brackets. All right, so there's Booleans. SSIS data type is a DT bool. That's equivalent to a bit SQL Server type, and the .NET type is Boolean. So just keep in mind that really the moral of this story is that you're almost always going to be dealing with conversion issues, particularly in a data flow. When you're reading data from a data source, you need to be very sure of the type of data it is. And a lot of the data flow source components will let you do a mapping and define the data type that you're getting in from the data source. So pay attention to that, because otherwise, if you don't, you can have some very subtle, nasty errors someplace else in the data flow that causes a problem for you. And it all comes back to you're working with a different data type than you thought you were. Another thing to keep in mind is that, as with most development languages and environments, data conversions can have a very negative effect on performance. So you're going to want to minimize the number of conversions that your package has to do as it processes data. Now, this is a very, very big topic. So if you want to get into the nitty-gritty details of integration services data types and conversion issues, a really good place to start is the integration services data types topic within Books Online. Fortunately, Microsoft provides a lot of resources for helping you wade through the data type issues, particularly with conversions. Okay, so you're going to need to cast from one type to another all the time, particularly within the data flow pipeline. But do the conversions as little as possible. And how you do that while avoiding data errors and getting the best performance out of a package is going to vary widely depending on the nature of your data and the operations that the package has to perform on it. So I'm not going to spend a lot more time on these kinds of issues, but just be aware it's a big topic and do more research into it. Okay, let's talk about variable scope. All variables in integration services have a scope associated with them. Scope describes how widely a variable is visible and usable within a package, and its components. To use variables effectively, you need to understand the effects of scope on variable availability. Now, variable scopes form a hierarchy. The package level scope forms the highest level node, and every task or container object forms a node in the scope hierarchy. Packages contain tasks and containers, each of which can in turn contain other tasks and other containers. In general, a variable is in scope in the container or task in which you define it, and all objects contained within that container or task have access to the ancestors variables. This is actually quite similar to the .NET framework in how a private class variable is in scope within that class and all of the methods, properties, and other code blocks within the class, but nowhere outside the class. Now, there are things like reflection and things like that. That's kind of a whole side issue. So there's not really an equivalent of reflection within integration services. Now, integration services doesn't allow the creation of global variables that are available across all packages in a solution. But because the package level scope contains all other possible scopes within an integration services package, variables that you create at the package level are effectively available as package global variables. So this is where scope gets a little bit confusing. Now, another thing that you can do is create parent packages that execute child packages. And the child packages, can see the parent's package variables. This is about as close to a global variable as you can get, other than things like configurations and parameters. Now, as of the version of integration services in SQL Server 2012, you can create project-level parameters that sort of act like global variables across all packages. But parameters are not as flexible as variables, so they're not really something you should try to use as a kludge for global variables. Usually there are better ways of doing that sort of thing. Now, the scope property of a variable is automatically set when you create a variable. Be careful where you create your variables. Make sure they're within the scope that you intend. The variables window does let you move variables. Move is kind of a funny word. It actually is really just changing their scope. I guess you're moving it from one scope to another. But you can only move them within the package. Unlike earlier versions of integration services, this gives you some flexibility to change a variable's scope if you find that you've created it incorrectly. But be aware that changing scope in an existing complex package may break things if you're not careful. Okay? All right, then also variable names are unique within their scope. This means that you can reuse existing variable names within different scopes. Doing that is going to effectively hide the variable in the higher level scope. For example, say you have a variable called filename within the package level scope. And then you create another variable called filename, same name, within the scope for a data flow task. Within the data flow, you'll be able to access only its own filename variable. And in other components, you can only access the package level variable. So this is generally how scope works in most programming languages. So you really want to be careful not to accidentally hide parent scoped variables, because that could cause unpredictable package behavior. Now, within Integration Services package, you have the ability to call another existing Integration Services package using the execute package task. So this is a great way to modularize a package and make parts of it reusable. The parent scope is the container for the child task. The child package can access the parent's variables, but any variables declared in the child that have the same name as the parent variable is going to hide the parent. So that's the kind of issue that you can get into. So parent variables can be a powerful tool for creating packages. They allow you to create modular packages that handle very specific tasks. But child packages that expect variables to be available and initialized by a parent is going to have problems if you attempt to execute them as standalone packages. You can resolve that problem by using parent package configurations, which I'm not going to cover in this part of the course. All right, so that's just really a quick rundown on some of the issues and why variable scope is important. Now, I've mentioned parameters a couple times. Parameters are a long overdue feature of integration services that finally debuted in SQL Server 2012. Like parameters and methods and functions of many programming languages, parameters essentially let you set the value of a variable externally. A parameter is actually quite similar to a variable in that you can use it to store information and use it in expressions. But parameters have a few different properties and uses. Among others, parameters have a required property. This is the name of a property, required. And that lets you require that a value for the parameter be set before the package will execute. Also, an expression can't change the value of a parameter, unlike variables. So within a package, parameters are essentially read-only. Now you can create parameters for either a project or a package. So project-wide, in which you have many packages, or for a single package. So you can think of this as the parameter scope. Those you create at the project level are available in all of that project's packages, whereas those you create in a package are available only in that package.